Hi, this is Nikki Lynham from educatingnow.com, and this is going to be a little vlog on multiplying decimal numbers. So if you are a subscriber to our teacher resource bundle, then you have access to this information. We have a few videos on how to multiply decimal numbers using the base 10 blocks as well as area models. But this is really for some troubleshooting. I've had a few teachers write in saying, I've just tried this with my class and it totally bombed. I have been working in some classes doing this, and it's certainly really challenging for students. And the other reason I'm doing this is for parents, because we're also having parents saying, hey, I want to help my child at home. They're not understanding this. I've never seen this before. And they're looking for a video. And I've looked for quite a while online to see if I could find one. But a lot of them don't really use the right language to describe what it actually means. So that's what we're going to do here. Just a couple of things before we get started with an example. So one of the reasons why a lot of students encounter difficulty with this is because they're not thinking conceptually. And the procedure for multiplying with decimals is actually really simple. It's one of the easier procedures because it's almost exactly the same as multiplying with whole numbers. And I am going to get into that a little bit at the end. But the concept of multiplying decimals and dividing with decimals is actually probably the most challenging in all of the grade 7 math if you actually are trying to figure out what the heck does this mean. So in order to really understand it, there's a couple of underlying understandings that need to come before. So like some prior knowledge. One is that multiplication means groups of. Okay. And the other underlying understanding is what decimals mean, and understanding that they're a part of a whole, that they're a fraction, right? They're tenths or hundreds. So those two things need to happen before students are going to be able to understand what we're doing here with the blocks. So I'm going to show you one example with the blocks. What I've done is I've put tape on my base 10 blocks, and I'm going to see if I can tape them to my whiteboard. I'm sure there is a far more fancy high-tech version, but I don't know what that is, so we're going to do it this way. Okay. So as we are looking at an example here, we have got 1 2/10 multiplied by 2 1/10. So first of all, I want to back up a little bit and remember that this means groups of. So 1 times 2 just means one group of 2. Well, this means it's not just one group of 2 1/10, but we have to find one full group of 2 1/10 and 2/10 of a group of 2 1/10. So we're essentially finding a little bit more than one group of 2 1/10. So that is where I'm going to start, because I'm always going to start with an estimate so that I know if my solution is reasonable. And I know one group of 2 1/10 is 2 1/10. So I'm going to estimate that it's going to be maybe around 2.5, 2 5/10, somewhere around there. So if we want to look at how we model this with the base 10 blocks, I tell my students to just start with the full number of groups first. So I'm going to ignore my 1 or my 2/10, and I'm just going to look at one group of 2 1/10. Let's see if these stick. So these represent one whole in this case. So this would be 2 wholes. And then if these each represent one whole, then these sticks represent a tenth, because 10 of them fit in there. I would not be doing this with these base 10 blocks until the students are very familiar with the base 10 blocks. And I actually start with multiplying numbers less than one whole, so that they've already become quite familiar with the idea that when we multiply two numbers less than a whole, we're taking a fraction of a fraction or a piece of a piece, and they end up with a smaller product. So this is certainly not where I would start. This is where I would introduce the idea of multi-digit decimal multiplication. So what you see here now is one group of 2 1/10, but that's not what I have. That's only part of it. I now need to find 2/10 of a group of 2 1/10. And that's what I love about these base 10 blocks for using this as a model is, as you can see, I have 10 rows going across here. And in each row, I've got this length and that little piece there. So 2/10 of this whole amount is just these 2 rows, or what's equal to these two rows. And in blocks, so right now, this would be 1/10 of 2 1/10 when I get these on here. And the other thing I love about this is it's using the area model. So we're reinforcing ideas about rectangles. It will always make a perfect rectangle if they've done it correctly. And it also links to whole number multiplication if they've done it with area models. So let's see if I can do this without all of these falling off. This is now 2/10. Obviously, when you do this on a desk, it's going to look a lot nicer, but just want to give you the understanding here. So this represents, this right here represents 2/10 of a group of 2 1/10. This is 2/10 of this whole amount. So altogether now, what I have is one full group of 2 1/10. That's this, and 2/10 of a group. And my is, you can see I have 2 wholes. I have 1, 2, 3, 4, 5 tenths, and I have 2 hundredths. So altogether I have 2 and 52 hundredths. And it's a nice area model that is linking, like I said, to, and not only does this link to whole number multiplication, but it also links to when they start multiplying mixed numbers with fractions, they can use the same model. And when they multiply binomials, when they get into high school, they can use the same model again. So underneath this, you could draw what we just did with the blocks as a sketch. Whoops, that was a terrible line. And some students like to get really particular and draw in at least those lines. Some of them like to do all of them. I think that takes up too much time, so I discourage that. But if they want to do this, and then we're going to label. So as you can see here, this is one of my 2/10, and this is my 2 wholes, my 1/10. So when we multiplied it, you can see here we have 2 wholes there, which makes sense because it's a 1/2 rectangle. Now this is one group of 1/10, which is just 1/10. Here we have 2 groups of 2/10. So you can see altogether, I've got my 4/10. And then these 2 little guys are hundredths because I took 2/10 of 1/10. And when I take 2/10 of 1/10, I'm just taking that little piece, just those 2 little guys there. And when I add those all up, if you wanted to do it this way and write it all out, you could. You get the exact same solution. 2 wholes, 5/10, 2 hundredths, 2 wholes, and 52 hundredths. So that's what this means. So again, it's those groups of. I'm going to take these down and I'm going to model another one for you that is, I'm just going to use the sketch. So hopefully you'll be able to follow along just because it's a little bit more manageable than the blocks. Now, teaching this in the classroom, I would be doing many examples with the blocks, and that language is so key, right? So always, how many whole groups and what part of a group do we have? So let's look at another example with an area model sketch. So we have a little bit more. So where students really struggle is, again, understanding that idea of a fraction of a group. It's usually around the 2/10 of a group. Understanding one group of 2 2/10 is no problem for most of them. But as soon as we get into what does 2/10 of a group of 2 1/10, like, that's pretty challenging. That's why I said I think it's the hardest concept in our grade 7 curriculum. Okay, so let's take a look at another example. And notice my estimate was pretty good. And we want them to estimate by rounding the numbers to whole numbers, just so they know about the ballpark. So let's look at something with maybe some larger numbers. So let's do 3 2/10 multiplied by 4 7/10. So first off, we're going to estimate. So students will see that that's pretty close to 3. That's closer to 5. So my estimate's going to be somewhere around 15. Next, I'm going to draw a area model sketch. So, and again, this is a sketch. It's not going to be super accurate, but if you did it with base 10 blocks, you absolutely could. This is getting pretty large. I wouldn't choose numbers this big. When you work with base 10 blocks, you want to keep these numbers pretty low and these numbers low, which is why we don't use them always. They're there for the first bit to help them understand what's happening, and then we want them to transition into the pictures if possible, so that they can still be thinking about what's actually happening, not just following a process or a rule, but it's a little bit more efficient. Grid paper is also something you could go to after this if you use not necessarily the 1 centimeter squares, because the grids are, or the squares are too big, but just normal graph paper. And I like to photocopy that and make it darker so the lines are a little bit more, you can see them a bit more. And then students can be modeling this using the graph paper too. So that's another pictorial sort of scaffold you could give them. But here we go. So I'm going to have, so if I started it this way, I'm going to say this is my 4 7/10. And at this point, I'm just going to have 3 groups. So imagine with your blocks, you had 4 of those big ones, and then 7 of the sticks. And I'm doing that 3 times over. That's why I would do this with blocks, because you probably don't even have enough for them to do that. So they would have 3 groups of that. But the question isn't 3 groups of 4 7/10. It's 3 2/10 of a group. So my last piece down here, just like I did before, and if you want to do, I probably shouldn't do that because I didn't fill it in on the other one. It would be confusing. You could have done 7 sticks going down there so they can actually see it. Again, that's a scaffolding way, but I find that most students, if they've had plenty of time with the blocks, coming to this is not so bad. If they're not ready to come to this, keep them with the blocks. So now what we have is we have, again, if I ignored this, 3 full groups of 4 7/10. Well, I'm going to have 12 holes, and I have 3 groups of 7/10. So if you can imagine 7 sticks lined up, 3 rows, of that, you're going to end up with 21/10, which is the same as 2 holes and 1/10. This is why it's so important that students have such a strong understanding of decimals before we get into operating with decimals. I often see teachers doing operations, adding, subtracting, multiplying, dividing with decimal numbers, but the students don't even know what a decimal number is. They just look at it as a whole number with a dot in front of it. So we need to really make sure that we start with the blocks, understanding what decimals are, understanding that 10 hundredths makes a 10, that 10 tenths makes a whole, and so on. And again, Educating Now has lots of lessons for that if your students don't yet have that understanding. Now, my 2/10 of this means that I need to take 2/10. If I imagine this with my blocks, again, I'm going to have 10 rows of that. I want 2/10 of that, so 2 of these rows. So I've got 2/10 of 4 holes. Which is going to give me my 8/10. And then this is that little piece. So I'm taking 2/10 of 7/10, which is going to leave me with 14 hundredths. Then I'm going to add these all up. So I've got, I can see, if I look, even if I'm doing this mentally, I can see that I've got 8/10, 9/10, 10/10. So I've got another hole just right there, plus that one. So that's 3. Plus my 12 makes 15 holes. And what I didn't use yet or include was my 400s. Obviously, very welcome to, and again, you can talk about place value. How did I know to line those up if I was going to line them up and stack them? Well, because I understand that I add whole numbers to whole numbers and tenths to tenths. And if I don't have tenths, that's okay. It just means there's 0 tenths. Some people always tell students to put a dot and do the zeros. That can help them with the procedure, but they need to understand that 12 holes is the exact same thing as 12 holes and 0 tenths. and it's still the same as 12 wholes and 0 tenths and 0 hundredths. You would be amazed how many students don't actually know that. If we want to add all the zeros in, you can do that. And do it that way, you'll get the same thing. And again, our estimate was pretty good. So the whole idea again of this is that we are taking 3 and 2 tenths groups of 4 and 7 tenths. So a little bit more than 3 full groups of 4 and 7 tenths. And we can do it with the blocks or with an area model. So we do eventually want students to see the connection. And when I do this in the classroom and we start with multiplying whole number or decimal numbers that are less than 1, students start to see that there's a connection between whole number multiplication and decimal number. And we want to encourage that connection. So when I talk about teaching conceptually, I don't mean that we don't ever teach them the most efficient procedures. I just mean we don't start that way. And the reason we don't start with that is because if students have a quick way of finding the answer, they are totally not interested, the vast majority of them, in doing all of this work to develop a conceptual understanding. We also know that when we teach procedures first, students, and with there's no understanding, it's not retained. Students don't remember how to do this. And that's what I see all the time. Or worse yet, they do it totally incorrectly because they've got different rules mixed up. This one I often see with decimal multiplication, they get it mixed up with decimal addition, and they feel they need to have to line up decimals, and they start doing all these kind of wacky things. Some of them just count decimal places, but then they skip them in from the wrong side. So if we incorporate conceptual understanding, we use our estimates, then we do move them toward, hey, are you noticing that these things are similar? And because it is a base 10 system, we will see all these patterns with decimal numbers and with whole numbers. So let's just take a look at how we can link those together. So just using the exact same example here, I'm just going to erase those bits. We can ask students after they've done something like this, we can say, hey, why don't you now try 32 times 47 and compare and contrast? What do you see that's similar and what do you see that's different? I'm just going to adjust my camera so that you can actually see what I'm about to do here. Okay, so if I do another area model, it's going to essentially look the same. The difference is I'm using whole numbers. And if you've never seen an area model for whole number multiplication, the reason we teach this is because this model does not go extinct like the traditional algorithm. It's used for whole numbers, decimal numbers, fraction numbers, and algebra numbers, algebraic expressions. Whereas the traditional algorithm is only good for whole numbers and decimals, and only if they do the decimals correctly. The other reason we use it is because it has a visual component. It shows them where the biggest portion should be because these are the largest numbers. And notice that I'm multiplying numbers, not digits. Okay, so when we do the traditional algorithms, we're reducing all of math to digit math, which if students understand the place value that's embedded within those algorithms, no problem. In my experience, most of them don't. And then when we ask them to do things like estimate, they can't estimate because they've never practiced anything bigger than 9 times 9, which reminds me, I should have done an estimate here. That would be 30 multiplied by 50. So we know it should be somewhere around 1,500. So back to my model here. I'm just going to finish it up. I'm going to add all my pieces together. So I've got my 1,200 plus 210 makes 1,410, 1,490, 1,504. So as we can see, same digits. Now, when we get to this point in the lesson, I do let my students know, because we're not going to use the blocks forever, if they're really struggling with this piece because their decimal multiplication is still not up to snuff, another option is to let them know once they see this connection. I allow them to see this connection by giving them lots of examples. I even sometimes have given them, I give them a whole bunch of questions where all the digits are the same, but the decimals are in different places. And I give them a calculator. And I say, what do you notice that's similar about them all? And what do you notice that's different? And it kind of proves to them. And then I get them to create their own and they share with a partner. And by the end of it, they're like, oh, wow, like they truly understand because they've seen it. They've been proven, like it's proven to them that the digits stay the same. And really what changes is place value, not where the decimal lives, but place value. I know those two things are kind of the same, but we want students to focus on place value rather than decimal, where the decimal point is. So back to this one, if we know that the answer to this question is going to have the same digits as this question, we could just simply jump right to this step if this is comfortable for students, have them do the multiplication, and then what we do is we revisit our estimate. So notice I'm not doing anything about counting decimal places. That's on purpose because I'm wanting them to engage as much number sense as possible. So when we go back to our estimate, we saw that the answer should be around 15. Well, when you look at this answer, there's only one logical place that decimal could possibly be, right? Otherwise, there's no way it's going to be anything close to 15. And that's where it would live. So that's another option. But again, ideally, students can understand each of the ways that I've shown you. So firstly, with the blocks, because we want them to see it as an area model and we want them to understand that whole idea of having a certain number of groups and then the decimal or the fraction of that same group. That was what I explained to you first. We also want them to be able to understand the area model pictorially. So being able to multiply decimals by whole numbers as well as decimals by decimals. And they've had that work with the blocks, so that should be review. And then finally, we can link them to how are these things the same and how are they different? And how can we use maybe a strategy, a method that's easier for us with the whole numbers and our estimating skill to figure out where that decimal lives. So I know that this is a completely different approach from how most of us were taught. I certainly was taught to multiplying decimals is easy. You just take out the decimal, multiply the whole numbers, and skip it back in. Again, the reason why we're moving away from that, without conceptual understanding, students don't understand the math and then they don't retain it. So what's the point? For them to be able to understand or for them to be able to do a procedure for a short amount of time, maybe do well on a test and then just forget it and have to relearn it again the next year and then again. That's not the goal. The goal is for them to understand it so that they retain it and then they can apply it. We also know that when we reduce the math to just digits, it doesn't build number sense. And we really want students here to understand the big idea that when we multiply numbers bigger than 1, the answer gets larger because we're taking more than one group of something. But if we're multiplying numbers less than 1 whole, then the answer actually gets smaller, which is the first time students at this age experience that. They always think multiplication gets the answer bigger. And so this whole idea of why does it get smaller, it's a really big concept, which is why we start there. So it's that understanding that we're starting with something less than 1 whole, so a little piece, and then we're taking 1/10 or 2/10 or 3/10 or 100th of that piece. So we're taking pieces of pieces. The other thing that really helps our students is when we use our proper language. Again, it's not 3.2, it's 3 2/10. And that is so that it has value. When I talk to parents about this, I always give the example. I say, would you ever call that number 42? And I say this to students as well. And they say, well, no, it's 42. So calling this 4.2 is the same as calling that 4.2. It's what it looks like, but it's not its value. So we want to make sure that we're using our language. All right, well, thank you for joining me for this vlog. I hope this is helpful. If you are struggling in your classrooms, if your students are struggling with this, first of all, this is a great time to remind them of those growth mindset messages, watching some videos. This is not supposed to be easy. Okay, so when my students are struggling, I say to them, great, because through this struggle will come really good learning. This is not supposed to be easy. We don't need to rescue them. We need to help them to be prepared for life by knowing how to persevere, how to be persistent in their learning, to have the grit, and to have that growth mindset so that they're resilient. And how we create that is by helping them to work through struggle. And we give them the blocks to help them see what it means. We use our language, that groups of, and taking a piece of a group, because it's not a full group if it's 2/10 of a group. And we do that with enough times, students will make sense of it. We need to give them time to conceptualize this. This is a tough topic. So don't plan on doing this in a lesson or two. This may take way more time than that. You can also have students breaking off into groups. And if some of them are still really struggling with the blocks, then they're going to be doing some questions with blocks. Maybe they roll dice to figure out their questions, or you give them a sheet and they work together, they talk it through, they write to explain how you model this with the blocks. And you want to give them plenty of opportunity to practice with the area model, the blocks, as well as linking it to whole number multiplication. So lots of different ways to access it. And we really want to just let our kids know that, yeah, this is challenging. And if they just figured it out instantaneously, they're in the vast minority, because understanding this concept conceptually, super challenging. I'm guessing you parents that are watching are probably thinking, I still don't get this yet. That's okay. I've only given you a couple examples. Try it a few more times, but remember that you're taking groups of and pieces of groups of. Thanks for joining me. And if you are not yet a subscriber to educatingnow.com, we have videos and lesson plans that will help you teach all of these concepts to your students. So check it out. Have a great day.